So student, today we are going to determine the Rockwell hardness number for a given specimen. So basically the Rockwell hardness number can be determined in two scale, in B scale or C scale. So basically in B scale we measure aluminium specimen or copper specimen or brass, gunmetal or different copper alloy. And in C scale we measure the cast iron specimen or mild steel or maybe different kind of steel and alloy steel. So for our experiment today actually we have this metallic specimen, and basically this specimen it is made of high carbon steel. So for this specimen we need to use the C scale. So basically two scales is there in our dial gauge. So in our dial gauge you can see there is two scale. The red one it is B scale and the black one it is C scale. So this is our dial gauge, and in our dial gauge two pointer is there. One is a small pointer, or you can say it small needle, and another is long needle, or you can say it the long pointer. So this is about our dial gauge. So for this experiment we need this setup, basically Rockwell hardness testing machines, and with it we require indenter, basically indenter. So basically two type of indenter it is used. So as we are here actually making a Rockwell C test. So for Rockwell C test we need diamond cone indenter. Okay, so this is the diamond cone indenter. The vertex angle of this indenter it is 120 degree. It will be used for cast iron or different kind of steel. And another indenter is there, that is the ball point indenter. So the diameter of the indenter is 1/16 inch. So today only I am going to use this indenter, that is diamond cone indenter, as we are using the high carbon steel, actually steel sample. So first for this determination, the sample what we have, first we need to make it clean, as there will be no dust, dirt or the oil. So absolutely this will be cleaned, and after that the surface actually on which we are going to determine the Rockwell hardness number, the surface will be smoothed with the help of grinding or with the help of polishing. Actually the surface should be absolutely smooth. So after that this sample can be used on the machines. So now I am actually setting this indenter, setting our diamond cone indenter with our penetrator, or you can say it the thrust member, with the help of this Allen key. So with the Allen key we need to set this indenter with the thrust member, or you can say it with the penetrator. So after this, according to the indenter and according to the specimen, we need to select the load. Basically this is our load member. So for C scale we need to select 150 kg load, 150 kg load. basically for the steel sample or for the cast iron sample, we need to select the 150 kg load, or if the sample it is aluminium or some other copper alloy, so we need to select the 100 kg load. So for our specimen we are selecting from this load selector 150 kg load. Here you can see the lot of load selections is there, 100 kgf or the 60 kgf. So among these actually according to our indentar and our specimen we are selecting 150 kgf load. So after this we need to put this specimen on the table. So we are putting this specimen on the table, then we are rotating this hand wheel. Basically when we will rotate this hand wheel in clockwise direction, so the specimen will get contact with the indenter. So okay, I am rotating or I am continuing my rotations, and we need to continue these rotations up to the small pointer reaches the red spot. So I am coming to this. So here as the small needle it reaches to the red spot. As you can see here, the red spot here is the red spot. So when the small pointer reaches the red spot and the long pointer reaches the zero, so up to this we need to rotate our hand wheel. So now we have set our specimen to these devices, and now it is put our main load. So one thing I can tell you here, that when we are setting when we set this our specimen to this table and the pointer in this position, so already 10 kgf preload is there on the specimen. We are select here 150 kgf load. So for this setting already 10 kgf load is there on the surface of the specimen. So now it is the time to apply the main load. So with the help of this hand lever, so with the help of this load lever actually, now we like to select the load. So now the load lever it is at position A. It is now position A. It is unloading condition. So when we apply this load lever to position B, so main load will be applied on this specimen. So I am applying the load on this specimen, and we need to wait until the long needle it is absolutely on rest position. So 10 to 15 second we need to wait actually for steady conditions of this long needle. So now very gently actually I am releasing our load lever from positions B to A. So the reading actually this time we can take from our dial. So the reading, as you can say student, as we are measuring actually we are using C scale. So for the C scale it is the reading, you need to take your eye level. So according to my observations actually the reading is 38. Okay, so the C scale reading it is 38. So now I need to rotate again the hand wheel in anti-clockwise directions to release the load and to remove the specimen. So I am removing the specimen. So now it is the time to calculate. So what reading we are getting from our dial, it is 38. So now student, let's do our calculations. So basically we have used our specimen, and the load which we have applied on the machines, that is 150 kgf. So 150 kg we have applied the load. So now it is need to take the load in Newton. So we need to multiply the G with this 150. So 150 into G, it is our load in Newton. So if we take the value of G, it is 10. So the load which we have applied on our specimen, that is 1500 newtons. Okay, it is the load in newtons. So now our black scale reading. So as we have done our Rockwell C test on our metallic specimen. So for C scale, we need to take the reading from the black scale. Black scale, that is the C scale in our Rockwell Hardness testing machine. So our reading was 38. So basically this 38, it is our reading, and this is the hardness value. So basically this number, it is our hardness value. So now if we like to find the depth of the indentation, basically when we are applying the load, the indenter actually it get indent on the surfaces. So the formula is 100 minus n. N is the value of hardness number. So 100 minus n, that is 38 into 2. So that will be the depth of indentation in micron. Okay, in micron. So why it is micron? So according to our machines actually, one division is equal to the 2 micron. So in our machines, one division is equal to 2 micron. So basically 62 into 2, that means 4. So micron. So depth of the indentation, it is 124 micron. So it is our depth of the indentation. So now how to write this hardness number? So basically the Rockwell hardness number should be designated by HR. So basically it should be write like this, HR, and proceed by the hardness value. So what we get our hardness value? So we get our hardness value, it is 38. And supplemented by a letter indicating the scale. So as we are using C scale, so we need to write this hardness number like this, 38 HRC. C means hardness, Rockwell hardness number on the C scale. So student, I think this determination of this Rockwell number, it is now clear to you. So thank you student, thank you to join us.